Hey guys, I'm Adwita Nikam and welcome back to my channel. Today we are going to learn something very interesting. If your science exam is around the corner and you haven't started chapter 5 yet, don't worry. In the next 10 minutes we are going to cover the most important topics of this chapter that you absolutely need for your exam. No unnecessary theory, no boring explanations, just the concepts that actually matter. So go grab your notebook if you have one and let's begin. Here's our roadmap. First, we'll understand what mixtures actually are. Then we will learn about true solutions, concentration, how concentration is expressed, solubility, and finally the three important methods used to separate homogeneous mixtures. Sounds like a lot? Trust me, by the end of this video, it will all connect together. Let's start with the most basic question. What exactly is a mixture? Imagine your mom is making a lemonade. She adds water, sugar, and lemon juice. Now tell me, did any new substance get created? No, the ingredients are simply mixed together, and that's exactly what a mixture is. A mixture is formed when two or more substances are physically combined and each substance still keeps its own properties. Now, mixtures are of mainly two types: homogeneous mixtures and heterogeneous mixtures. A homogeneous mixture has the same composition throughout. Every part looks exactly the same. For example, salt dissolved in water. No matter where you take the sample, it will have the same composition. On the other hand, a heterogeneous mixture does not have a uniform composition. Take sand and water. You can see the sand separately. Different parts look different. Now let's see what a true solution is. A true solution is a homogeneous mixture. Here, the solute particles are extremely tiny, smaller than 1 nanometer. That's why you can see them with your naked eye. They remain evenly distributed through the solution. Think of it like this. If someone secretly dissolved sugar in your water, you won't be able to see the sugar particles. That's because they're incredibly small. That's a true solution. Let's revise quickly. A mixture is a physical combination of two or more substances. Homogeneous mixtures have uniform composition, and heterogeneous mixtures have a non-uniform composition. A true solution is simply a homogeneous mixture with extremely tiny particles. Great! Now we know what mixtures are. But here's the next question. Imagine I add just 1 spoon of sugar to water and you add 10 spoons. Both are sugar solutions, but are they equally strong? Absolutely not. That's where our next topic, one of the easiest topics in this chapter, concentration of solutions, comes in. Imagine one more scenario. I have 2 glasses of lemonade. In the first glass, I just add 1 spoon of sugar. In the second glass, I add 5 spoons of sugar. Which one will taste sweeter? Obviously, the second one. But why? Because it has a higher concentration of sugar. So, what exactly is a concentration? Concentration simply means the amount of solute dissolved in a given amount of solvent or solution. In simple words, more solute means more concentration and less solute means less concentration. Based on this, we have two types of solution: a dilute solution and a concentrated solution. A dilute solution contains a small amount of solute dissolved in large amount of solvent. For example, just a pinch of salt in a glass of water. Concentrated solution contains large amount of solute dissolved in solvent. A good example is saturated salt, where a lot of salt has already dissolved. One common mistake students make is thinking that concentrated means saturated. That's not true. A concentration solution simply has more solute than a dilute one. A saturated solution is something we'll learn in the upcoming slides. Now, here's the part that many students memorize without understanding: the formulas. But trust me, once you know the logic, they are super easy. Scientists don't say a solution is concentrated. They like to express concentration mathematically. And for your exam, there are three important methods. First one is mass by mass percentage. Second, mass by volume percentage. And last, volume by volume percentage. First one, mass by mass percentage, is written as m by m percent. The formula is mass of solute divided by mass of solution multiplied by 100. Remember, mass of solution means solute plus solvent. That's a very important point. Suppose we dissolve 10 grams of sugar to make 100 grams of solution. The concentration becomes 10% mass by mass. The second one is mass by volume percentage. Here we divide the mass of the solute by the volume of solution, then multiply by 100. For example, 5 grams of glucose are dissolved in 100 milliliters of solution. The concentration is 5% mass by volume. And finally, volume by volume percentage. This is mainly used when both the solute and solvent are liquids. Here, the formula is volume of solute divided by volume of solution multiplied by 100. For example, 20 milliliters of alcohol in 10 milliliters of solution gives 20% volume by volume. Here's a simple trick. Look at the name, mass by mass. Both the quantities are masses. Mass by volume, one mass, one volume. Volume by volume, both the quantities are volumes. The name itself tells you the formula. Now, here's another interesting question. Can we keep adding sugar forever until it keeps dissolving? Let's find out. Imagine you are stirring sugar into a glass of water. The first spoon dissolves, the second spoon dissolves, and the third spoon also dissolves. But after some time, you'll notice that the extra sugar simply settles at the bottom. Why does that happen? Because the solution has reached the maximum capacity to dissolve the solute. This maximum amount of solute that can dissolve in 100 grams of solvent at a given temperature is called solubility. If no more solute can dissolve, the solution is called saturated solution. If more solute can dissolve, it is called an unsaturated solution. Temperature also plays an important role. For most solid substances, increasing the temperature increases their solubility. That's why sugar dissolves much faster in hot water than in cold water. Perfect. Now we've understood solutions, how they are formed, how their concentration is measured. But what if we want to separate the substance again? That's exactly what we'll learn next using crystallization, distillation, and paper chromatography. Here's another interesting question. What if we don't want the mixture anymore? Suppose someone accidentally mixed sugar with water or mixed alcohol with water or mixed different colors together. Can we separate them? Yes, and that's exactly why scientists developed different separation techniques. In this chapter, you only need to know three important methods: crystallization, distillation, and paper chromatography. But here's something very important. Every method works because of the different property of the substances. So don't memorize the names. Understand why each method works. Let's look at them one by one. Let's begin with crystallization. Imagine you have prepared a solution of copper sulfate in hot water. Now you leave it undisturbed and allow it to cool. Beautiful blue crystals begin to appear. But why? Because as the solution cools, the solubility decreases. The solution can no longer hold all the dissolved substance. So the extra solute comes out in the form of pure crystals. That's the principle behind crystallization. Crystallization is mainly used to obtain pure solid crystals from a solution. For example, preparing copper sulfate solution crystals. Remember this line. Cooling decreases solubility, leading to crystal formation. This sentence alone can fetch you marks. Next comes distillation. Imagine you have a mixture of water and alcohol. They look exactly the same, so filtration won't work. Then how do we separate them? We use their boiling points. Every liquid boils at different temperature. The liquid with lower boiling point evaporates first. Its vapor is then cooled and converted back into liquid. This process is called distillation. Distillation is used for purifying water and separating miscible liquids. Finally, probably the most interesting method, paper chromatography. Have you ever drawn something using a black sketch pen? It looks black, but is it really made of one color? Surprisingly, no. Black ink is actually made up of different colored dyes. Paper chromatography separates these colors. How? Different substances move through paper at different speeds. Some move faster, some move slower. As a result, they separate into different colored bands. This method is commonly used in laboratories for forensic science, food testing, and ink analysis. One easy way to remember all three methods is crystallization, is solubility, distillation, boiling point, paper chromatography, different speeds. Remember these three keywords and you will never confuse the methods. One more thing, on my channel I have a visual representation of all three methods in the form of shorts. So I'll attach the link in the description. Do check out that. Before we finish, let's quickly revise the points that students most commonly forget. A solution is a homogeneous mixture. The solute is the substance that gets dissolved. The solvent is a substance that dissolves the solute. Don't confuse concentrated with saturated. Always remember mass of solution equals mass of solute plus solvent. Students often forget this while solving numericals. Finally, the three concentration formulas before your exam. And that's it. In just a few minutes, we have revised the most important topics of Chapter 5. If this video helped you understand the chapter, don't forget to like because it really supports the channel. And if you're preparing for Class 9 exams, consider subscribing because more exam prep guides are on the way. Thank you for thank you so much for watching. And as always, all the best for your exams. See you in the next one. Bye bye.